Okay, I want to go through your 3.3a and kind of focus on goal and process. I know it was kind of difficult to walk through it, so I want to walk through this with you, okay? Um, First thing is I'm going to always circle the goal in red. The cure is the goal, but we got to make sure we understand that that goal is simply to take its derivative. One step, take the dir of f. That's all we have to do. And then you come strolling over here. Of course, Schroeder doesn't have everything on the paper. It should be an f there. But if I'm taking the derivative of that, then all they're asking me to do is take the derivative of this integral. And when I do that, that's the fu. So plug in. So plug in your u times its derivative minus plug in the second u. But as we know, you're going to get times 0, so it's gone. Answer is just 1 over x. Second one is another way to write the same thing. Here they're being real direct. Just take the derivative of the integral. So simply plug it in. Now here's where the algebra gets in some of our way. So I'm going to fu. So remember, when you plug stuff in, it is in parentheses. It's in parentheses. It's important. And then times the derivative. Then subtract, plug in the bottom, but when you plug in the bottom, you get times 0. So that's gone. You're left with just this, and that would give you sine x to the 6th. And this 2 to the x, I'm going to probably write in the front because that's a safer place to put it. And that obviously would give you your answer. Next one. Now we're getting into terms that we know what they mean, but we haven't applied it to this given circumstance. There is the operative word. And it says G is decreasing. That means your goal is to get the derivative to be less than 0. So I want it to be less than 0, and means I need to take the derivative and then check to see when it's less than 0. So step 1, get the derivative, and then look at the graph and see where it's below the x-axis. But I need that derivative function first. So if I want the derivative of x, I got to take the derivative of the function, which is an integral, which gives me, plug it in, times its derivative, and then you plug in the bottom when you get 0. So I have, my function is sine x squared g tick x. Okay, that's great, because see, now you can graph this in your calculator. And I don't have the graph of that in my calculator. However, I will quickly create that for you. On an interval from -1 to 3, it looks like this. It's over, touches, up, down, and up, and back down. I want to know where the derivative is less than 0. That's the goal. That occurs here and here. So I need to know, I need to find the zeros here and here, because it's everywhere in between here, which I'm not sure which one of those answers it is. I believe it's either, I believe it's this one. I'm not positive, but you can find the zeros there yourself. Next question. Of course, this is missing of course, it's missing a G. There's a G. Okay, find the goal. Where's it at? Graph where G has a point of inflection. Think about what that goal means. That means you check the double and must change signs. Because that's what point of inflection does. The signs of the double derivative change, which would be really nice. If I can get the graph of the double derivative, then I can find it. But let's see what we're offered here. Oh gosh, they give me G. And G is the area under a curve. The area under that curve. But I don't want that. I want its derivative. So you take the derivative. If you take the derivative of that, you get just fx. Hey, so the derivative of g is just f. So that means it's the point on the curve. But I don't want that. I need the double. Well, if I took the derivative and got f, then the double has to be the derivative of f. Well, f is a graph, so it must be the slope on f, and the slope must change sign. Okay, so if you look at the graph, your slopes are positive, negative. So you have one change here, and then you have negative slope, positive slope, second change here. So it occurs both at 2 and 5. The crest response is 2 and 5. Number 5, okay, reach for the goal. Now, if I'm not mistaken, there's two parts here. Find the dir of f, and then plug in 2. There's two things to do. 2. Separate. Do one thing at a time. Don't worry about plugging in the 2 yet. So let's once again, this stupid thing copies and loses an f. Okay, so this guy, take its derivative. Now be careful here. I already see a u that has a u tick. And I also see where it might have a problem with squaring something. So fu times u tick. Remember, when you're plugging it in, it is in parentheses. Times the derivative of u, 2. Minus, plug in 4, whatever, but then you're timesing 0. So this whole thing will disappear again. It is a constant. So it's just going to give you derivative 0, so it disappears. So there's your f tick. Now I want f tick at 2. Please plug in 2. If I'm not mistaken, that is square root of 16 subtract 4 times 2, which is equal to square root of 12 times 2. And look at the choices. 2 times square root of 12. They could have done some nasty stuff with that, but they didn't. All right, next one. Goal. If the where G is non-negative. Now this one's actually a very dirty question. They're not asking me to take its derivative or anything. They're just saying, hey, G is the area under the curve. But notice how they have a fixed constant 0. So what we're going to do is I'm going to try some numbers. I'm going to start with, I don't know what x is. So let's try G1. G1, I'd be doing the area under the curve from 0 to 1. Well, if I shade that region, I have this much. That's a positive number. So 1 is a choice. I want a non-negative number. So that's 1. So 1 works. Let's try 2. If I look at 2, that's area under the curve from 0 to 2, because remember that 0 is fixed. If I look at the graph, the area under that curve is this much. That's still positive. Try 3. At 3, I'm going from 0 to 3. Now take a look at the graph now. You've got all this area again, all this. And then I've got to take this, which is negative. But if I put it all together, that's still going to equal a positive number. It's still on the positive side. So right now I've chosen every number 1 to 2 and 3. All of those work. Here's the dirty. Check these out. Let's pick a negative one. It says start on 0 and go to negative 1. First of all, you should have issues with that. That means it's backwards. So let's put a negative in front and switch it so it's the correct order. Now let's just look at that region now. That region is from -1 to 0. That's negative. But right here, that's negative, but we have another negative. So therefore, it has to be a positive number. Same thing's going to be true for G2, G -2. You've got 0 to -2, but you're going to switch it. But if you switch it, you're still getting the area from -2 to 0. That's all this area. That's negative, but it's got a negative in front, so it becomes greater than 0 again. And again, if you add the -3, this part right here is actually going to be negative. So, but this is all positive. That's negative. Therefore, the whole thing is positive. So the answer is every number worked. They all give me non-negative numbers. I like this question. This question is the graph of this but I got a bing, 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 bing. And I don't see any goal established here in the words. But if I look, they're asking for the function in all of them. Oops, not all of them. But all of them have, all A, B, C, and D all have the function, its derivative, and its double derivative. They all have those in some combination. So I'm going to have to figure out what all of them are. So H6. Well, that's just plugging in 6. So I'm going to plug in 6. Well, that's x. This is x. So it goes where x is. And this is the area under curve. If the area under the curve from 0 to 6, that's clearly a negative number. So that's negative. Now let's look at the derivative. The derivative at 6 would be take the derivative and then enter 6. If I take the derivative of the integral, I get h6 is just f6. Well, that's no longer, that's the point at x equals 6. If I look at that, that's right here. That's 0. So that's equal to 0. That's a donut. The last one is the derivative. If I have the derivative and I'll take the derivative again, that means I need to take the derivative of this guy, which is f6. That's the slope of f at 6. Going back up to the graph, if I look at the slope at 6, I know for sure that is a positive number. Now all I have to do is order these guys. This one's negative, this one's 0, this one's positive. This one is the smallest, biggest. A is the choice. Okay, remember tonight, review all your EKs, and tomorrow is formative. So it's like your first assessment. You get a reassessment on Friday. All right, have a good evening. See you tomorrow.